Welcome to another edition, a Monday edition of CMA 8th Grade Math Academy. Mr. Schrag here to help you guys learn the formula for the volume of spheres. And that is what we will be learning today. And we're going to use that to solve real-world problems that involve spheres. Why do we need to learn this? Last week you learned the cylinder and cone formulas for volume. This is the next step and the final formula in order to complete your ability to solve for the volume of curved figures. How will you know when you've been successful? When you're given a real-world problem about a sphere, you will know what the important parts of that problem are, plug them into the formula, and solve for the volume. So today's video is going to be slightly different along the same lines, but instead of jumping right into the book, we are going to practice with the formula once, and then we're going to jump into the book and use that formula to actually solve the problem. So here on the left, I've got the formula, and then I've got a sphere. Just to kind of recap from our notes that we took about a week ago, the sphere is an object created when all the points on the outside are the exact same distance from the center. Okay, and we know the radius, just like with a circle, can be found at any point on the sphere to the center point, the center of the sphere. The dotted line that is shown on this drawing is the great circle. That is the circumference when we think about it that way. I kind of think about it like the equator of the Earth. Okay, right in the middle of that sphere, going all the way around. It's like the largest circle you could draw if you were to cut that sphere in half. Okay. All right. So similar to the formulas from cylinders and cylinders and cones. Sorry. We have pi, and we have radius to a power. This time our radius is to the third power instead of last week our radius was always to the second power. So for spheres, it's to the third power, radius to the third power, and the rest of the formula is just 4/3 times pi times that radius once we have it to the third power. And throughout this lesson, just make sure you are using 3 and 1400ths as pi. Okay, that's what your book does, and all the answers in this video will be based on pi as 3 and 1400ths, not the pi button on your calculator. Okay. So just to practice one here, I have listed that the diameter is 10 inches. Okay. Well, if the diameter is 10 inches, then we know that the formula calls for the radius. So just like we had to do several times last week, we're going to have to turn the diameter into a radius. But that's very simple because we know that the radius is just half of the diameter. So in this case, the radius is 5. Because if we divide 10 in half, we're going to get 5. Now we have a number that we can plug in for our formula. So the formula is volume equals 4/3 times pi, which we're just going to use 3.14, times the radius to the third power, the radius cubed. So here it's 5, so we would have 5 cubed. And then all we do is type that exactly as you see it into the calculator using the parentheses, just like that. And when we do that, here we get the volume is equal to 523. And you get a whole bunch of 3's after that. We're just going to round to the hundredths, so 33/100ths. So our final answer is 523 and 33/100ths. And this was in inches. And we know it's volume, so it's cubed. So it's inches cubed. And that's our final answer. Really as simple as that. Okay, so formula, not too bad. Now we know the formula. As long as we have the right pieces, plug them in, and we get the volume. Okay. The more challenging part of this section is going to be reading the problem and understanding what pieces are important, what pieces aren't, picking out the information we need and solving from there. So let's go ahead and jump in. We're going to be starting on page M5 117. There are 3 problems on this page. We're going to do the first one together, and then we'll go from there. So just another note at the top there that says we're going to use 3 and 1400ths for pi. So instead of using that pi button on your calculator, make sure you're using 3 and 1400ths. All right. Number 1 says Earth has a diameter of approximately 7,926 miles. Okay. Just to start, I know this one doesn't have a whole lot of information, but to get into the habit, because some of these are going to have a lot more as we get to them. So the important information here would be that it is a diameter. Okay, if we don't know what we're working with, if we don't know if it's a volume or radius or diameter or circumference, we're going to get lost. So make sure you're always taking note of what the information is. Okay, so it's the diameter, and it's saying that it's approximately this many miles. Okay, that's really the only important information we get on this one. And A says determine the length of the radius of Earth. Well, we already know how to go from the diameter to the radius. I don't need to teach you that. We've been doing that a lot already. So I'm going to go ahead and just give you 15 seconds. It shouldn't take long. Convert that diameter into the radius. Ready, go. And that one shouldn't have been too tough. All you got to do is take 7,926. That's the diameter, so we divide it by 2 to get radius. And then we know that our radius is going to be 3,963. Just make sure you have the label of miles on there. Okay? And now that's good because question B says determine the volume, and we know our volume formula requires us to have the radius. So we already did that in question A, saves us from having to do it here. So we know the formula is volume equals 4/3. It's always 4/3. That number never changes. Times pi. That number never changes. And then it's the radius cubed. So in this case, we take that 3,963, and we're going to cube it. And I'll give you just a second to type that into your calculator. And once you hit enter, you're going to get a really large number. And that number is 260 billion 711 million 882,973 and 32 hundredths, and that is miles. And because it's volume, we know we always cube it. So that is our answer. And there you have it. You have already found the volume of a sphere. Now we're going to go ahead and skip to question number 2, right below it. So I guess we're not really skipping anything. This one is maybe a little bit more challenging. So it starts out and says that the circumference of an NBA basketball ranges from 29.5 to 30 inches. Okay, so the information that's given, let's go ahead and highlight that again. This time it's giving us circumference. Now it's giving us 2 numbers, so if we ever have to solve, we're going to have to pick. And question A tells us which one to pick. So question A says, calculate the approximate length of the radius. Okay, we're looking for the radius if the basketball has a circumference of 30 inches. So that one tells us which to use. Because if we didn't know if it was 29.5 or 30, that would change our answer. It's telling us, okay, use the 30 inches. That's your circumference. Now let's work backwards and find radius. So if you recall from your Cornell notes, some of you may have those out and handy. Circumference formula, the circumference of a circle is 2 pi times radius. Okay? 2 times pi times radius. So if we plug in the things that we're given, the information that we're given, we know that the circumference is 30 inches. The 2 and the pi, we're going to use 2 and then 3 and 14 hundredths. And we know that that is times the radius. The radius is what we're going for, so we don't know it yet. Now, this is a problem where we're going to have to work backwards. So the formula is multiplication, so to work backwards, we know we use inverse operations, just like we're solving an equation, and we're going to have to divide. So we're going to end up taking 2 times pi, which is going to give us 30 equals 2 times 3 is going to give us 6. 2 times 14 is going to give us 28 times the radius. Now we're going to divide by that number on both sides. And when we do that, that's going to leave us with the radius. I'm out of room, so I'm going to write it over here. So the radius, when we divide in the calculator, is going to give us 4 and 78 hundredths, and that is in inches. That is just a length, not a volume, so we don't need to square it or cube it. It's just inches, so it's 4 and 78 hundredths of an inch. Now again, that sets us up really nicely for question B because it's asking for the approximate volume of the basketball. And it gives us the circumference again, but we know that's the same circumference as letter A. And letter A, we found the radius, so now we can plug in the radius into the formula. So we know that volume equals 4/3 times pi times radius cubed. In this case, our radius is 4 and 78 hundredths, and then we're going to cube that. And when we type all of that into our calculator, we get 457 and 25 hundredths. That was in inches, but it's inches cubed because now we're talking about the volume of something. And there is our answer. Now let's go ahead and go to the last question on page 117. Now this one is even a little bit different. So we have given is the volume of a Major League Baseball. So this is the volume, so that is important. We haven't had a question like this yet where it gives us the volume. We've always had to get the volume. That's been the end goal. So it says the volume of a Major League Baseball is 12 and 77 hundredths cubic inches. All right. So now we know, okay, if they're giving us volume, chances are we're working backwards at some point here. So question A says, calculate the approximate length of the radius of a Major League Baseball. All right, so we know that radius is in our volume formula. Okay, so I'm going to put our formula up here just as a quick reminder. So we know that volume equals 4/3 times pi times radius cubed. Okay. Now, if we plug in what we know, well, the only thing we're given is volume. So I'm going to go ahead and plug that in. We know that the volume is 12 and 77 hundredths, so that is going to equal 4/3 times pi times radius cubed. Okay. Alright, so I'm going to go ahead on my next step and take that 4/3 and multiply it times pi. So when I do that, I end up getting 4 and 187 thousandths. Okay, I rounded that because it was really, on my calculator I got 186 repeated, a whole bunch of sixes, so I just rounded that 6 to a 7, so now I have 4 and 187 thousandths, and that is still times the radius cubed. And on the left side of that equation we still have 12 and 77 hundredths. Well, we can tell right away, well, we need to get that coefficient away from the r. Well, that's multiplication, so the opposite of multiplication is division, so I am dividing by 4 and 187 thousandths on both sides of the equation. And when I do that, I get an answer of 3 and 5 hundredths, and that is equal to my radius cubed. And now I know the only step left is getting that radius to just be r instead of r cubed, and we know the opposite of cubing something is cube rooting something, so we are going to end up having to cube root, not square root. That's the square root sign, but with a 3 in the left corner. If your calculator does not have a cube root button, you can instead type this in. Let me make a little note of this here. You can instead type this in your calculator as 3 and 5 hundredths to the 1/3 power. So you can say, if your calculator doesn't have a cube root, you can type in 3 and 5 hundredths and then hit your, I call it a caret key to make it a power, and then do parentheses 1 divided by 3, and that will give you the same answer. So cube root is the same as taking something to the power of 1/3. Okay? And when you do that in your calculator, you should come out to get radius equal to 1 and 45 hundredths. And that was in inches, so we know our answer's in inches, and the radius is never cubed or squared, so that is our final answer for letter A. Now, question B is not asking for the volume, again, because the volume was given. We know the volume, we know the radius. Question B is asking for the circumference. Well, that's as easy as plugging into our formula. So we know circumference is equal to 2 times pi times the radius. Well, our radius here was 1 and 45 hundredths. And when you type that into your calculator and get an answer, you end up with 9 and 1/10. And that is again in inches. And circumference is an area of a measurement of distance, and so it is not squared, it is not cubed, it is just left in inches. Alright, so I really like this page 117, because it gives you 3 examples of different types of real volume questions you could have. Okay, question 1 gave you the radius, gave you the diameter, but we found the radius. Once you had the radius, you found volume. Okay, so that's one type that you'll see. Question 2 gave you a circumference. You had to work from the circumference backwards to get the radius, and then once you had the radius, you found the volume. Okay, so that was the second type. So the first type was you're either given the diameter or the radius, you just plug it in the formula and solve. Question 2 gave you the circumference. From that, you had to work backwards to find the radius. Once you had the radius, plug it in the formula, find the volume. Easy. Okay. Question 3 then, gave you the volume, and you had to work backwards. That was the third type. So you have three really good examples of the three main types of questions you're going to get about the volume of a sphere. Okay? So with that, we're going to go to the next page, page 118. And now remember, you have 117 as a good help if you get stuck on any of these. Okay? So question 4, I'm just going to get you started, but you're going to actually do the work. Okay? So it's a longer problem, gives us a lot more information. So this time I'm going to read it, but I am going to pause. And as always, you guys are going to fill in the blank when I pause. All right, everybody's reading. Here we go. Built in the 1950s by the Stamp Collecting Club at Boys Town, the world's largest ball of postage stamps is very impressive. The solid ball has a of inches, weighs pounds, and consists of postage stamps. Calculate the of the world's largest ball of postage. Okay, so this one is just asking for the volume, okay? But the tricky part here is there's a whole lot of information above. And if you choose the wrong thing to plug in to the formula, you're not going to get the correct volume, okay? So as you're reading through here, that first paragraph, or the first sentence, sorry, you probably noticed that I didn't pause at all and have you guys read. Well, that's because that whole first sentence, while it might be some details, is not any important details that we need to know. None of that is going to help us solve the problem, because the problem just wants us to calculate the volume. So then in the second sentence, I did stop and I had you guys read several things. Okay? You guys read the word diameter. You guys read some numbers. And so I did that because I wanted you to pay attention to what the information that they were giving. Well, we know that if we're finding volume, we need to know the radius. And we know if they give us a diameter, we can find the radius. So the diameter being 32 inches is really, in this whole paragraph, the only thing that's important to us. That's the only thing we need. Okay, so with that information, knowing that the diameter of 32 inches is important, I want you guys to go ahead and work. And if you get stuck, I want you to turn to the previous page, 117, and look at question 1, because this is the process we did in question 1. Okay? I'm going to give you guys 1 minute. Ready, go. All right, so hopefully you've had time to come up with an answer. Question 4 here, we determined that they gave us the diameter of 32 inches. Well, we know that if the diameter is 32, then that means that our radius has to be 16. So hopefully that was the first step you took. And after you did that, then you know that the volume is just 4/3 times pi times the radius, which in this case is 16 cubed. Okay? And when you type that into your calculator, remember typing in 3 and 1400ths for pi, you end up with a volume of 17,148 and 59 hundredths. And that was in inches cubed. All right, good job on that one, not too bad. And so now, question 5 at the bottom, I'm going to give you an even less help. So this time, there's a whole bunch of information. You're going to read it yourself. You're going to pick out what's important, and then you're going to solve. Okay? Since there's a lot more to read and you're doing all the work, I'm going to give you a little bit more time. You're going to have 2.5 minutes to work on this one, and then we'll come back and check. All right, ready, go. All right, so hopefully on question number 5, you kind of realized that that first part wasn't that important. That whole first paragraph But really, the information that we needed in order to solve this was given in the second paragraph, where it said that the circumference along the great circle was 133 inches. That's information that can help us solve this. So the first thing we have to do on this one, and hopefully you did, was find the radius based on the circumference, because we need the radius to find the volume. So the circumference formula is circumference equals 2 times pi times the radius. And if we plug in what we know the circumference is 133. That's going to equal 2 times pi times the radius. And then when you work backwards to solve and you divide that by 2 times pi, divide this by 2 times pi, you end up with the radius being approximately 21 and 178 thousandths. Okay, if you rounded that to 21 and 2/10 or 21 and 1800ths, that would be okay. Just know that your answer might be slightly different than mine. So then when we plug that into the volume formula, so then we take that radius, and we know that volume is 4/3 times pi times the radius cubed, and in this case I'm plugging in that number for my radius cubed. And when you type that in your calculator and get an answer, you come up with an answer of a volume of 39,761 and 4/100ths, and that is inches cubed. All right, that one was a little bit tougher, but still nothing we can't handle. Question number 6, which is at the top of page 119, says that the world's largest disco ball hangs from a fixed point and is powered by a 5-ton hydraulic rotator. It weighs nearly 1.5 tons with a volume of approximately 67 cubic meters. Approximately 8,100 square centimeter mirror tiles and over 10,000 rivets were used in its creation. All right, another one of these that gives us a whole bunch of information, most of which doesn't help us, but it does say right in the middle of all that the volume is approximately 67 cubic meters. The question is asking us to calculate the radius. So, again, this is one kind of like question 3 was, where we have the volume and we got to work backwards. So, just to remind us, volume is 4/3 times pi times the radius cubed. And we're going to have to work backwards. So let's go ahead and start by plugging in what we know. We know that this is 67 is the volume, and that is the only information that we're given. So the rest we're going to have to solve from there. So I'm going to plug that into the formula first. And our next step is going to be multiplying that 4/3 times pi. And again, we did that on a problem earlier today, and that's going to give us 4 and 187 thousandths, and that is times r cubed. And on the left side, we still have 67. We know we're going to have to use inverse operation, so we're going to divide by 4 and 87 hundredths on both sides. Sorry, 187 thousandths. I think I said 87 hundredths. And when we do that division, we end up getting 16, and that is equal to r cubed. Now, if this was r squared, we'd know right away, oh, 16 is a perfect square, and it's 4. But this is cubes, not squares, so we need to cube root it. And again, if your calculator doesn't have a cube root, you should just multiply 16 to the power of 1/3. And when we do that in our calculator, we get 2.5 equals R. So we know that R is going to be equal to 2.5 meters, because that is what the volume was in, was cubic meters, and that's our answer. Alright, you guys have done really well with all of this, finding the volume today. And so your homework for today is to finish page 119. We just did question 6, so you're going to do questions 7 and 8 for homework. Question 7, you're calculating the volume. Question 8, the volume is given, and you need to determine the diameter, so you're going to have to work backwards on that one. Alright? Alright, good job today.